Okay, here I have an oscilloscope, and when you first see it, you see these signal coming in, and the signal's not going to change, but we can change the way we view it. Okay, so the signal's set, and this could be an electrical signal or a sound signal coming into an oscilloscope. It's a wave signal. Okay, so I can change the vertical here. I can also change the horizontal, which won't make a whole big difference yet, but let's change this. The first thing is to do is change it so that we can view it. That looks good. See, that's a nice wave. And then I'm going to change this a little bit. Ooh, there we go. Too tall. Maybe I'll just leave it like that. And then I need to move it around, so let's vertical it. Move it vertically. Then let's move it horizontally. And you can even grab this background here and center it like this. Center it like that. But anyways, I'm going to move this signal so it's right in the center. And then I'm going to move the vertical so it's right on that line, just right there. Perfect. Now let's see if we got it centered. 1, 2, 3, 4, 5, 6. Down below, 1, 2, 3, 4, 5, 6. So my amplitude, which is the peak amplitude, which is from the middle to the top, is 6 divisions. So 1, 2, 3, 4, 5, 6. So, but it's not 6 volts, it's 6 divisions. But each division is 0.1. Okay? And so that means our volts, in this case, is 6 times 0.1. Oh, I got that wrong. See, check this out. That's milliseconds, which is seconds are left and right, and then volts is up and down. So according to our volts here, it's 0.5 volts, okay, for every division. And there's 6 divisions from here up, so 6 times 0.5 will give us 3. So this is a 3 volt signal. The amplitude of this wave from the middle to the peak is 3 volts, 3 volts peak amplitude. Now let's find the period of the wave. The period is the time it takes to go there and then repeat to another same point on the wave. So I'm going to go from crest to crest. We could go from this point all the way to the repeating point over here, but instead I'll just do crest to crest. It's easy. I've set it up. I've centered it. I'm going to count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is it 11 divisions? Let me double check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, it's 11 divisions. And then each division is 0.1. See that up over here? Because I can change that, but then it messes things up. Since each division is 0.1, I'll do 11 divisions times 0.1. And what's 11 times 0.1? Let's see, it's divided by, so it's 1.1. So my period is 1.1, not seconds, but 1.1. If we come over here to the right, it says milliseconds for every division. So it's 1.1 milliseconds. Okay, that is how you find the peak amplitude and the period. If you want to find the frequency, you just inverse the period. But don't forget, milliseconds is 1/1000th of a second. So when you inverse it, your frequency should be a very big number.